video, we're going to go over section 7.2, which is called trigonometric functions and right angles. So this whole section is specifically for right angles. There are 6 basic trigonometric functions. We have sine, cosine, and tangent. So sine, cosine, and tangent. And we also have what are called our reciprocal functions. Those are cosecant, that's an S, cosecant, secant, and cotangent. Cosecant, secant, and cotangent. Whenever we are referring to right triangles, we have this little saying that helps us remember how those trig functions relate to the sides of the triangle. You can see I've got my right triangle drawn over here on the right hand side. This bottom leg, or first we should note that we have this angle here called theta. That's the Greek letter theta. This bottom leg, or the leg that's touching theta, the leg that's touching theta down here, that's called the leg adjacent to theta, or just adjacent. We abbreviate that ADJ. The side that is straight across from theta is called the leg opposite theta. Again, we would abbreviate that opposite, OPP. And then the hypotenuse is the longest side in the right triangle, and we just abbreviate that HYP. It's always, the hypotenuse is always directly across from the right angle. All right, so that right angle is denoted by that little box in the corner. All right, so this little box right here. All right, so again, we have this little, not sure what you would call it, little saying or phrase to help you remember how these trig functions relate to the sides of the triangle. It's called SOHCAHTOA. I usually write it like this, SOHCAHTOA. All right, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. All right, so SOHCAHTOA. Now let me just briefly mention the 3 other trig functions, cosecant, secant, and cotangent. Again, those are called your reciprocal functions. These are called your reciprocal functions. Because they each match up with one of those 3, they each match up with either sine, cosine, or tangent, and they're just the reciprocal of that trig function. All right, so sine, the reciprocal of sine is, let's make a little table here, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. All right, so those are super important. Let me just highlight all the super important stuff from, well, I wanted to, but the board's not letting me today. But SOHCAHTOA is super important. And then remembering how these reciprocal functions match up is also super important. So sine matches with cosecant, cosine matches with secant, and tangent matches with cotangent. All right, so get out your unit circle let's take a look. It says evaluate the exact value of each of the following expressions. Now, your book is going to tell you a different way to do this, but I just want to show you a little shortcut. Whenever you're looking at the unit circle, cosine represents the x-coordinate, and sine represents the y-coordinate. Right, so for example, on part A here, it says evaluate cosine of 30 degrees. We would write that as cosine is abbreviated COS, cosine of, so little parentheses, cosine of 30 degrees. So you would go to the angle 30 degrees and you would identify the x value or the x coordinate at that angle. So go over here to 30 degrees, right here. X coordinate is square root of 3 over 2. So cosine of 30 degrees is square root of 3 over 2. So whenever you see something like cosine of 30 degrees, you want to think x coordinate at 30 degrees. All right, so secant, well, I should abbreviate that, sorry. Secant is abbreviated SEC. So secant of 30 degrees, that's just going to be the reciprocal of cosine. So you just take your value for cosine here and take the reciprocal. So that would be 2 over the square root of 3. They do not require that you rationalize this on the homework. So you don't have to worry about getting rid of that radical in the denominator, which is nice. And then for part B, we have sine and tangent of pi over 4. So sine is abbreviated SIN. So sine of pi over 4. So again, you would go to your angle pi over 4. That's right here. Right, sine is the y value. So the y value at pi over 4, the y coordinate at pi over 4 is square root of 2 over 2. All right, but let's talk about tangent. We didn't say what tangent represented. We said cosine represented the x-coordinate, sine represented the y-coordinate. Tangent also has a special representation on the unit circle. So tangent is the y-coordinate divided by the x-coordinate. All right, so the y-coordinate over the x-coordinate. All right, so tangent at pi over 4, or tangent of pi over 4. All right, so that's y over x. All right, so go to your angle of pi over 4, right here in green. So it's y over x. So square root of 2 over 2 over square root of 2 over 2. Now, these are the same, so they're just going to cancel out and become 1. But if you were doing this and they weren't the same, you'd have to do keep, change, flip. But we know that these are exactly the same, so they cancel out and become 1. All right. Let's look at number 2. It says, evaluate the expressions using a calculator if necessary. Round your answers to 4 decimal places. All right, so I'm going to grab my calculator, and we're going to plug this in. I'm going to switch over to the document camera. I'm going to plug these in. Okay. So let me pull up my document camera. All right. All right, so here we go. Zoom that in a little bit. All right. All right, so part A says evaluate sine of 3 pi over 11. All right, so 3 pi over 11, that's in radians. So you want to make sure that you're in radian mode. You can see right here, I am in radian mode. If you're not, you could just hit the mode button and then change yourself over to either radians or degrees, whatever you need to be in. In this case, we need to be in radians. All right, so we're going to do sine. Sine is right here. See right there, it's 2 buttons above the 7. So there's sine. Notice that we only have buttons on the calculator for sine, cosine, and tangent. So we'll talk about how do we figure out, values for things like secant, cosecant, cotangent. All right, so sine of 3 pi over 11. All right, so it says round to 4 decimal places, so that's 0.7557. Right, so sine, whoops. All right, and then it also wants us to find secant of 3 pi over 11. All right, so secant of 3 pi over 11. All right, we know that secant is the reciprocal of cosine. All right, so secant is the reciprocal of cosine. So we'll just do 1 over cosine of 3 pi over 11. Let's do our little fraction. 3 pi over 11. Close parentheses. Enter. And there we go. 1.5270. 1.5270. All right, next we have tangent of 87 degrees. All right, so we have a tangent button on our calculator. Again, it's right here. It's above the 9 right here. All right, so we'll do tangent of 87 degrees. We need to be in degree mode. So I'm going to go to mode. Change myself over to degrees. There we go. Just hit enter once you're blinking over that degrees. Change it over to degrees. Hit second mode. That's going to quit. Take you back to the home screen. All right, so tangent of 87. You don't have to put the degree symbol in there. Your calculator knows that that's a degree, an angle in degrees. So it's in degree mode. All right, so that tangent of 87 degrees is 19.0811. All right, and then our last one, cotangent of 7 pi over 11. What mode should we be in? That's what you want to ask yourself every time you start one of these problems. What mode should I be in? I should be in radian mode, so I'm going to go back to radians. I know that because my angle, it doesn't have any units attached to it, so I know that if there's no units indicated, then I must be in radians. All right, so cotangent, we know that is the reciprocal of tangent, so that's going to be 1 divided by tangent of 7 pi over 11. And it's okay to get negative values, so that's negative 0.4567 if we're rounding to 4 decimal places. Okay. All right, let's go look at some stuff about degrees, minutes, seconds. All right, so if you want to be more exact when you're using When you're using degrees, then you can use something called degrees minute second notation. It says in the context of angle measure, 1 minute, it uses just a little apostrophe for minute. 1 minute is 1/60 times 1 degrees. And 1 second, which is 1 with 2 little apostrophes, is 1/3600 times 1 degree. So really this is what's important here. Just this part, whoops. This part right here. So you don't need to write that middle part for 1 second. All right, so if I was trying to, condense this to be as small as possible, or to be as little writing as possible, then I would write 1. Okay, well, first of all, if I could get it to go back to the pen, that would be helpful. No? Okay. All right, so if I was trying to condense this down to write it as small as possible, I would say 1 minute equals 1/60 degrees. 1 second equals 1/3600 degrees. And then I gave you an example down here of how you convert between degrees, minutes, seconds, and degrees. So again, this is converting from degrees, minutes, seconds. We usually abbreviate that DMS to degrees. All right, so that would be 14 degrees, 37 minutes, 23 seconds. So you would just do 14 plus whatever the minutes is over 60 plus whatever the seconds is over 3600. So it's not terribly complicated, but this is something that you'll see come up on the homework a few times. On the test, I won't put degrees, minutes, seconds on any of the problems. I'll just do regular old degrees. All right, so here we have an example of converting between degrees, minutes, seconds, and decimal notation. All right, so we have 23 degrees, 10 minutes, 44 seconds. All right, so if we were going to convert this to decimal notation, we would do 23 degrees plus 10/60 plus 44 over 3600. Then we just plug this in the calculator. All right, so let's get our calculator pulled up here on our document camera. All right, so it doesn't matter what mode you're in right now. We're just, simplifying fractions and converting them to decimals so that you don't have to be in degree mode for this to work. 23 plus 10/60. Whoops. Let me try that again. 23 plus, and we'll do a little fraction. 10/60 plus little fraction. 44 over 3600. And convert that to a decimal. So math. Convert to a decimal. So I just hit the math button right here, and then the second option was convert to a decimal. All right, so there we go, 23 point, let's see, we're supposed to be rounding this to 4 decimal places, so that's 23.1789. And don't forget the degree symbol on the end. All right, so like I said, not terribly difficult to convert between degrees, minutes, seconds, and decimal notation, but it does come up several times in the homework. So now you know how to convert those. So here we go. Here's an example with degrees, minutes, seconds notation. The rest of these examples in this section are going to be word problems. So it says, before cutting down a dead tree in your yard, you decide to determine its height. Backing up 40 feet from the tree, you use a theodolite and note that the angle between the ground and the top of the tree is 61 degrees, 55 minutes, 39 seconds. How tall is the tree? All right, so a theodolite is an instrument used by surveyors to estimate the angle between ground and something up in the air. So let's draw a picture here. We're going to draw a little tree. Drawing the picture always helps you visualize what trig function you should be using. Let's see. We back up 40 feet from the tree, so back up 40 feet. And then we use a theodolite to measure the angle from the ground to the top of the tree. All right, so draw yourself a little line from the ground to the top of the tree. So starting over here, right, there's the top of the tree. And we estimate that angle is 61 degrees, 55 seconds. Or excuse me, 55 minutes, 39 seconds. All right, so you can see that forms a little right triangle right here. There's our right angle. All right, so now you're going to look at, we want to know how tall is the tree. So which side would that represent? Would it be, if this is the angle, would it be the opposite or the hypotenuse? That would be the opposite side, right? So let's just call that tall, T for tall. All right, so that's that side in red over there. All right, so you look at what you know and you look at what you want to know. So we have this angle, we have the adjacent side, and we want to know the opposite. So you ask yourself, what trig function relates an angle to the adjacent and opposite sides? All right, so think back to your SOHCAHTOA. Which trig function relates adjacent and opposite? That would be tangent. So SOHCAHTOA says that tangent of theta equals opposite over adjacent. All right, so now we're going to plug in what we know. Theta, our angle is 61 degrees, 55 minutes, 39 seconds. Let's go ahead and convert that to degrees, back to decimal notation. Well, actually, we'll do that in a minute. Let's just go ahead and write in what we know. Sorry. Tangent of theta, so that's going to be tangent of 61 degrees, 55 minutes, 39 seconds, equals opposite over adjacent. Opposite side was T, adjacent side was 40 feet. All right, and now we got to figure out what T is, so we're going to multiply both sides by 40 to get T by itself. All right, so multiply both sides times 40 times 40. All right, that's going to cancel out the 40 in the denominator. And then you have 40 times tangent of 61 degrees, 55 minutes, 39 seconds, equals, sorry, go away. Just trying to make that minimized. All right, so equals, the 40 canceled out from the denominator, so it's just T. And now we can plug this in our calculator. So let's get over here, look at our document camera. Where's my document camera? There we go. All right, clear out anything you got in there. Decide what mode you should be in. We should definitely be in degree mode, right? Our angles in degrees, minutes, seconds. So go to mode, put yourself back in degree mode. There we go. All right, and start typing this in. So you can see at the top up here, it says I'm in degree mode. So I'm ready to go. 40 times tangent of, now I got to convert this to degrees, to decimal notation from degrees, minutes, seconds. So 61 plus
55 over 60 plus. I can make that into little fractions if you think that looks better. 55 over 60 plus little fraction, 39 over 3600. All right, so I wanted to wait to the end to do that conversion because I didn't want to round in the beginning and then mess up our answer. So that's why I waited to the very last step to convert to decimal notation from degrees, minutes, seconds. So I avoid any rounding mistakes. There we go. Let's see. We're going to go ahead and round this to 75 feet. So T is 75 feet. And I know it's feet because that was the units the problem was in. All right, so T is 75 feet. All right, let's look at our next problem. All right, so it says the manufacturer of a 16-foot ladder recommends that when in use, the angle between the ground and the ladder should equal 75 degrees. What distance should the foot of the ladder be from the base of the wall it's leaning against? So you may have to pause this if you're writing down the questions, but I'm going to go ahead and draw my wall. And then here's my ladder. All right, and then here's the ground. So I've got my wall, got my ladder. Well, I was trying to fix those little lines in there, but of course it doesn't want to let me. All right, so you can just imagine that that actually looks like a ladder. All right, so it says that the angle between the ground and the ladder, that's right here, should be 75 degrees. And it says that my ladder is 16 foot long. So here's the ladder, this part right here. So that means that my hypotenuse here of this right triangle, my hypotenuse is 16 feet. All right, and again, here's that's my right triangle. And it says, what distance should the foot of the ladder be from the base of the wall? All right, so base of the wall is over here on the left. Here's the ground. The foot of the ladder is down here on the right, so that's going to represent this bottom leg here. So we're going to call that D for distance. All right, so let's look at what we have. We know this angle. We have the adjacent side and the hypotenuse. All right, so which trig function relates the angle with the adjacent and the hypotenuse? That would be cosine, right? So cotoa. So cosine theta equals adjacent over hypotenuse. Then you plug in what you know. We know the angle is 75 degrees. We know that the adjacent side is D and the hypotenuse is 16. All right, so to get D by itself, to figure out what the distance is, you're just going to multiply both sides by 16. That's going to cancel out 16 in the denominator. Let's see. All right, so we should be in degree mode. We are in degree mode, so that's 16 times. Let's see if I can move this over a little bit because it's all kind of getting jumbled up. Yeah, that looks better. All right, so 16 times cosine of 75. And there we go. We'll round this to, let's do 2 decimal places, 4.14. And this again is in feet. 4.14 feet. All right, let's look at our next one. All right, so it says the angle of elevation, that means the angle where you're looking up. The angle of elevation of a flying kite is 75 degrees, 50 minutes, 43 seconds.
if the other end of the 52-foot long kite, or the 52-foot long string attached to the kite is tied to the ground, what is the approximate height of the kite? All right, so round your solution to the nearest foot. All right, so here's our kite, and then here's the string. Let me see if I can line it up. There's our string of our kite. All right, and then we'll go ahead and finish off this right triangle. There we go. This is the angle of elevation. That's again the angle from the ground looking up is 75 degrees, 50 minutes, 43 seconds. It says the string on the kite is 52 foot long. And they want to know what is the height of the kite. All right, so that would be this leg over here opposite the angle. That would be the height. We'll call it H for height. All right, so this time we have the angle, the opposite, and the hypotenuse. So angle, opposite, and hypotenuse. So which trig function is that? So Katoa, so that would be sine. So sine of theta equals opposite over hypotenuse. That's the formula. All right, so our angle theta is 75 degrees, 50 minutes, 43 seconds. Let's see if I can move that down here. All right, so it's opposite over hypotenuse. So opposite side is H, hypotenuse is 52. All right, so same thing from before. We just multiply both sides by 52 to get H by itself. It's going to cancel out on the right-hand side. And as we're typing this in, we're going to go ahead and convert it from degrees, minutes, seconds over to decimal notation. All right, so make sure you're in degree mode. We are. All right, so 52 times sine of 75 degrees plus 50 minutes, 50 over 60, plus 43 over 3,600. All right, so those denominators of those fractions always stay the same. It's just the numerators is where you put in the minutes and the seconds. And it said to round this to the nearest foot, so that would be approximately 50 feet. All right, so approximately 50 feet. So the height is approximately 50 feet. Okay. All right, so we have a radio tower has a 92-foot shadow cast by the sun. If the angle from the tip of the shadow to the top of the tower is 83 degrees, what is the height of the radio tower? Round your solution to 4 decimal places. All right, so we have a radio tower. We'll just do a plain old tower here. It doesn't have to be fancy. And it says that it has a shadow, so the shadow is down here on the ground. It says the shadow is 92 feet. And it says if the angle from the tip of the shadow, that would be down here on the right, to the top of the tower is 83 degrees. Right, so that angle is 83 degrees. What is the height of the radio tower? So again, we'll do H for height. All right, so this time we have the angle, the adjacent, and the hypotenuse. All right, so I'll go ahead and I'll write out which trig function we should use, and then I'll skip actually finding the answer because we've already done one exactly like this before. Adjacent and hypotenuse, that's cosine. Cosine theta is adjacent over hypotenuse. All right, so you would plug in your angle. Your angle theta is 83 degrees. adjacent side is 92 feet. I'm sorry, why was I doing hypotenuse? We do not know the hypotenuse. Woo, that was a close one. Sorry, you guys. You're probably thinking, why did I write hypotenuse there? This is not the adjacent, this is, or excuse me, that's not the hypotenuse, that's the opposite. Sorry. So we would write adjacent, opposite, that's tangent. SOHCAHTOA. So tangent theta is opposite over adjacent. That's tangent theta. Oops, not theta. I've already got messed up now. All right, so tangent of theta, which is 82 degrees, equals opposite is h, adjacent is 92. Again, you would just multiply both sides by 92 to get the height. Okay. All right, so here we have, I'm going to skip this one and then do number 9. The ramp of a moving truck touches the ground 17 feet away from the end of the truck. If the ramp makes an angle of 13 degrees relative to the ground, what is the length of the ramp? All right, so I skipped number 8 because I took that one off of the homework. So let's say here's a moving truck. So here's the truck, here's the ramp. It says the ramp of a moving truck touches the ground 17 feet away from the end of the truck. All right, so here's the ramp, here's the ground, 17 feet. That looks better. Now it doesn't look like my truck is like hovering. All right, so it says if the ramp makes an angle of 13 degrees relative to the ground, what is the length of the ramp? We'll call this L for length. That's just a little cursive L. So here we have the angle, the adjacent, and the hypotenuse. All right, so that would be cosine. All right, so cosine theta is adjacent over hypotenuse. So you would just plug in 13 degrees for your angle. Adjacent is 17. Hypotenuse is L. All right, so here's one that we haven't done before. All right, so let's go to the next page, and we're going to write cosine 13 degrees equals 17 over L. All right, cosine 13 degrees equals 17 over L. Just check to make sure that was right. Yep, 17 over L. All right, so we haven't done one like this before where our variable was in the denominator. All right, so let's look at what's going to happen here. We're going to start the same way. We're going to multiply both sides by the denominator, which is L. Multiply by L. It's going to cancel out on the right-hand side. It's going to leave you with L times cosine of 13 degrees equals 17. To get L by itself, we want to know what the length of the ramp is, so we're just going to divide by cosine of 13 degrees. Divide by cosine of 13 degrees. We're going to cancel out over here, leave you with L equals 17 over cosine of 13 degrees. Now let's go plug this in our calculator, make sure you're in degree mode. All right, so 17, we'll do a little fraction, 17 over cosine of 13. I am in degree mode. All right, let's see, it told us to round to 2 decimal places. All right, so that would be 17.45. And let's see, this was in feet. So the length of the ramp would be 17.45 feet. And that's everything for this section. My best advice for this section is to draw a picture and then, fill in everything you know, and then try to figure out, use your, SOHCAHTOA to figure out which trig function that you should be using. All right, let me know if you guys have any questions. Otherwise, I'll see you in my next video.